Welcome to today's lesson. So in this lesson we are going to look at how we can deal with graphs of polynomials. So we have been given a polynomial, and this is a 2018 past paper GCE. It should be GCE or grade 12, but it's 2018. So this is grade 12. This is a grade 12 question. Right, so if you have not yet subscribed to the channel, click on the subscription button, and if you have any questions, feel free to contact me using any of these lines on the screen. Alright, so let's quickly begin. So the question says, so the polynomial has been given, and what is just needed is for us to solve the questions that are down here. So the first question is, use the graph to solve the equations. So before you start finding the solutions to these questions, you have to understand one thing. What does it mean if they put a 0 this side, or what does it mean if they put an equation at the end of this polynomial? So when they say solve this equation, for instance the first equation, they are trying to tell you to say, since this equation, let me do this, we have the polynomial which is y is equal to x to the power 3 plus x to the power 2, then we have minus 12x. So now if they put a 0 where there is y, you have something like this. And if they decide to put a 0 this side, what does this mean? So in other words, they are trying to tell you to say the value of y is what? Is 0. So us putting a 0 this side is just the same as putting it on the other side. There's no difference. So them putting a 0 this side is just the same as putting a 0 where there's y here. Alright, so if they put a 0 this side, it means that the value of y is equal to what? 0. So in other words, they're asking you to find the x values at the point where y is equal to 0. So to find the values of x at the point where y is equal to 0, you simply just look at the line, or you find this line. So this line which is y is equal to 0 is simply just the x-axis. So in the x-axis, we know to say in the x-axis the value of y is what? 0. And then in the y-axis, in this axis, the value of x is 0. So now we are trying to look for this line on this graph. So this line, the line y is equal to 0, is simply just the x-axis. So if they ask you to find the solution of this equation when this side there's a 0, when they have put a 0 this side, it simply means that you are simply just getting the points at which the curve is meeting the x-axis, or the point at which the the points at which at which the curve is meeting this line. So this line is simply just the x-axis. So these 3 points are the solutions for the first equation. So the solutions are therefore, so the first solution is x is equal to, so at this point we have seen there is -4. So the first value of x is -4. The second value of x is 0. So we have x is equal to 0. And the third value of x is what? Is 3. We have 1, 2, 3. So we have x is equal to 3. So these are the solutions for the first equation. So let's quickly move to the next equation. We find what the solutions of this equation are. Alright, so in this case they have not put a 0 at the end, but instead they've decided to put another equation there. So we'll see what that means as well. So this is what we have, and this side they've decided to put x plus 10. Remember what I said, this part consists of y, or this part is we have y on the left. So now what if they put an equation this side? What does that mean? So it means that this part, if they okay, let me just write what I'm trying to say here. So let me let me rewrite this expression here. So we have x to the power 3, then we have plus x squared minus 12x is equal to y. So now, since this part is equal to that part, that tells us to say this part is also equal to that. So in other words, I'm trying to say the value of y is equal to what? X plus 10. So now this is a linear equation. What we have found here is a linear equation. So what do you do with this equation? You have to plot it on this same graph. So when you plot this equation, the points at which this line is going to meet the curve is the points at which this line is going to meet the curve are the solutions for what? For this equation that we've been given, this one. Okay, so let's quickly plot this one. So the way you plot this, you can make a table of values, and you have something like this, and you're going to pick 3 points from the graph. So I'm going to get okay, let me put 1, or get maybe 1 point from this side. I'll also get 0 and also get 1 point from the right. So I'll get negative okay, I want something that will give me a number that will be reasonable. Okay, I'll get negative 5. Then I'll also get 0, or let me get negative 4 this side, and then I'll get positive 4 this side. So what happens if I put negative 4 as x? I'm going to have the value of y as negative 4 plus 10, and this is going to give me what? 6. So I'm going to put 6 there. And what if I put 0 as x? I'll have y is equal to 0 plus 10. So meaning the value of y becomes what? 10. So I'm going to have 10 there. What if I put 4 here? What am I going to have? I'm going to have y is equal to 4 plus 10, and the value of y becomes what? 14. So this is what we're going to have. So now I'm going to plot these points on this curve, on this graph rather. So we have negative 4, 6. So negative 4 is there, then comma 6. So 6 is somewhere. We have 1, 2, 3, 4, 5, 6. So 6 is there. Sorry, it's positive 6, not negative 6. So it's supposed to go up. Let me just delete this point. So I'm going to count 6 steps going up. 1, 2, 3, 4, 5, 6. So that's the first point we have there. So that's our negative 4, 6. Then we have 0, 10. So 0, 10 is somewhere there. And then we also have 4, 14. So 4, 14. So 10, 11, 12, 13, 14 is there. So now I'm going to draw a line. I'm going to draw a line to connect these points. So this is what I'm going to have. Okay, so I'm using a computer, so this is not going to be very accurate. You are supposed to use a ruler to connect these points, and you are going to get at least solutions that will be closer to what the examiner wants. So you use a ruler to connect these points. So now at these 3 points where the line is meeting with the curve, that's where you get your solutions from. So don't be surprised if you get a bit different solutions to what I'm going to get, because I'm using freehand to draw this straight line, and you are supposed to use a ruler to connect these 3 points. All right, so let's take the x values of at these meeting points. Then we take those as our solutions. So we have the first point, which is there, and we come down. So this point, what is this? So we have negative 3 there. 1, 2, 3, 4, 5, 6, 7. Okay, let me count properly. 1, 2. Okay, we just subtract 2 from there. So we have negative 3.8. So the first solution is negative 3.8, comma. Then the other x value, we pick this point here. So I'm going to pick this point. This is just like 0.8. Yeah, so the other x value is 0.8. Let me just write it down. So we have x is equal to negative 0.8. Then we also pick this point there. So when we pick this point, this is like if you look at it properly, this is 3, 1, 2, 3, 4, 5. Okay, I'm going to get it as 3.5. So the other x value is simply just 3.5. So these are the three values of x that you need. I mean, these are the approximate solutions of this equation here. Alright, so let's quickly see what the other questions requires us to do. Okay, let's quickly solve the other questions. So in case you have questions on how to find the solutions or from what I've just done, feel free to contact me using the lines on the screen, and then I'll see how best I can help you. Alright, so let's quickly see how we can solve part 2 of this question. So the second part says calculate an estimate of the gradient of the curve at the point where x is equal to negative 3. So for this one, it's also a simple question. So let's see how to deal with such a question. So what do you do? So we've been taught to say we calculate an estimate of the gradient of the curve at the point where x is equal to negative 3. So we look at a point where x is equal to negative 3. So it's this point. So we have that point there. So what you do with this point is that you have to get your ruler, and then you draw a line that touches the curve at that same point. So this is how you do it. And then after doing that, you're going to get two coordinates in this same line, along this same line. And then those two coordinates are the ones that you're going to use to find the estimate of the gradient at that point. We know that the formula of the gradient is given by it's given by m is equal to y2 minus y1 over x2 minus x1. So this is the formula for the gradient. So now we need to find what y1 and y2 is, and x1 and x2 is. And where do we get those points? We get them from this same line that we have drawn on the screen right now. So the first coordinate that I'll get is simply just I can even get this same one, negative 3 comma. So at this point where x is equal to negative 3, I'll get it as, like I said, I'm using freehand to draw these lines, so I may not get the exact solutions that you are going to get when you're using a ruler, but the solutions will obviously be similar. Yeah, they'll be nearly the same. Maybe the only difference will just be decimal numbers. Alright, so I'm going to get negative 3. So the first point I'm going to get is negative 3 comma. This is like so this is something like this is like 18. Yeah, so I'm going to say negative 3 comma 18. The second point that I'm going to get is I'm going to get a point maybe at that point there. So this is negative 1 comma 41. So we have negative 1 comma 41. So these are the 2 points that I have. So I'm going to name this as my x1 y1 x2 y2. So now we plug them into the formula. So the gradient is now going to be equal to, so y2 is simply just 41, and then we say minus y1, which is 18. Then we say divided by our x2 is negative 1 minus x1 is negative 3. Then we have m is equal to 41 minus 18. So now you have to subtract that for you to get the solutions. So let us do the subtraction. So we have 41 minus 18, and that gives you 23. So you are going to write your 23 there, and then you also have to subtract the down part there. So you have -1 minus -3. So this is just the same as, let me write 23 this side. Down here is just the same as -1. Negative times negative will give you positive, and then you write your 3 there. So when you add what is down there, you get +2. So when you divide the 2, you are going to get so when you divide 23 by 2, you're getting 11.5. So 11.5, this is the gradient. So my gradient at the point where x is equal to -3 is simply approximately equal to 11.5. So you use this symbol to show the examiner that you know what you're doing. You tell them that this is not the exact solution, but this is just an approximation, meaning you use this type of equal sign. So you say the gradient is approximately equal to 11.5. So this is the gradient at the point where x is equal to -3. So let us now look at the last part of the question, which says the area bounded by the curve x is equal to -3, x is equal to -1, and y is equal to -10. How do you find the area in such a situation? So using calculus, this is a very simple question, but in this case we're not going to use calculus. We are going to use the trapezium rule. So these are very simple question. Okay, so we have been given that the area bounded by the curve, and then apart from the curve, we've also been given x is equal to -3, which is this point there. So I'm going to draw a line from the curve, this point. Then apart from that, we've also been told to say x is equal to what? -1, even that part. Then from there, we've also been told to say y should be equal to what? -10. So y should be -10. So in other words, we are finding the area of this part, because the line which is equal to y is equal to -10 is this one here. So meaning we're finding the area of this part. So what you do if you are calculating the area of this part, you can divide this part into as many trapeziums as you can, or parallelograms as you can. You can use trapezium rule or parallelogram rule. It's just the same, except that the formulas will be a bit different, but you end up getting the same solution. Alright, so this is the area that we are finding. This is the area that we've been taught to calculate. Okay, so now calculating the area of this shaded region is simple. So we're going to divide this into trapeziums. Yeah, so for you to be more accurate, you divide them into as many trapeziums as possible. But for me here, I'm just trying to show you the way. I'm just trying to show you how to solve this, meaning I'll just divide this into a few geometries. Yeah, so let me do this. Let me just remove this part. I was just shading that so that you know the area that you're supposed to find. Okay, so I'm going to divide this. I'm going to do that. I'm also going to do that. So I'll have the first geometry, which is A and B. But if you want, you can also do this so that you become, oh sorry, not like that, so that you are a bit accurate. You're a bit more accurate than me. You can divide it like this. At this point where it's turning, you cut, meaning you have something like this, meaning you're going to have A, B, and C. Yeah, that's accurate. That will give you something that is more accurate than what I'm doing. So they've asked us to find an approximation, an estimate of the area. We're not finding the exact area bounded by these lines and the curve. So if you use calculus, you're going to find the exact area bounded by the curve and these lines that have been given. But if you are using the trapezium rule, you are simply just approximating. It's just an estimate of the area. So for the first geometry there that we have, for the first shape there, which is I'm going to take this as a trapezium, and this part will be my A, this one will be my B, and my height will be this one here. Same applies to this part will be my A, this one will be my B, and the height will be this one there. So area A, so let me say the area is, the total area is going to be equal to the area of A and plus the area of B. So when we add the area of A, let me say area A and area B. So let me do this, plus area B. So let me find area A first. So area A is going to be given by half A plus B times H. So this is now going to be half. The value of A is simply just this distance from there to there, and the distance from here to here is 10, and then from there to there is this is like 18. So 18 plus 10 is going to give us 28, and then the distance from here to there, that's our B. So we have from here to there is 10, from there to there is 20, so 10 plus 20, that gives us 30. Then the height is just the distance from here to there, that's one unit according to the measures that have been given here. Okay, so the area will therefore be 28 plus 30, that's 58. So 58 divided by 2, that's 29. So area A is equal to 29, because when you multiply it with 1, you still get 29. So this is 29 units squared. Let's also find area B. So area B, we also do the same because it's also a trapezium. So if you have a square, you use the formula for the square. If you have a triangle or a rectangle, you use the formula for the rectangle or the triangle, depending with what geometry you have. So for area B, we do the same. So A is simply the distance from there to there. So you have from this part to that, that's 10. From there to there, so I'm going to count this as 12. Okay, so this, I'll take it as 12. 12 plus 10, that's 22. Then we're adding this to B. My B is simply just this longest distance here, which we said is 30. So this is 52. The height is the distance from there to there, which is also 1 unit. So when you do the calculation, 22 plus 30, you're getting 52. So 52 divided by 2, you are getting 26. We have 26 units squared. So now to find the area, we're going to add area A and area B. So the total area is therefore going to be equal to area A plus area B. That is going to be 29 plus 26. So when you add the two, you get so 29 plus 26, you are getting 55. So 55 units squared is an estimate of the area bounded by the x is equal to -3 and x is equal to -1 and y is equal to -10. So this is the area, this is the approximation of the area bounded by these by these lines and the curve. So we have found the area of this shaded region here, an estimate of this area. So if you use calculus, you find a number that is accurate and it will be closer to this. Alright, so thank you very much for watching today's tutorial. So see you in the next tutorial video. If you have any questions for grade 12s or A-level questions, physics, mathematics, chemistry, feel free to contact me using these lines on the screen. My name is Hamted. See you in the next tutorial video. Shalom, shalom.